So welcome to our fifth day of the intro course, which is we'll be going over strings. We've already used strings in Java and in Android. It's text, so you can't write a program without text, or you can't write very many. But we're going to dig into them and what they are, how they work, and all of those good things, and what you can do to manipulate them. And we'll do some fun things with string formatting, and then we will look at something specifically to Android with strings. So here are our objectives for tonight. Upon completion of this module, you'll be able to understand the role and use of strings, use string methods to manipulate string text, understand the benefits and drawbacks of StringBuilder, use interpolation to format strings, and understand the use of and reasons behind the string resource files in Android. So here's our assignment for today. We're going to be writing an app that can check to see if a string is a palindrome. And that's going to be a palindrome is a word that is spelled the same forward and backwards, something like level or madam or race car. Those are all spelled forward and backwards. So what we'll have to do is you'll have to look at each of the characters in your strings in whatever string the user submits and compare the first one to the last one, and then step close to the middle and compare those two, and then go to the middle and compare to those two and go to the middle until you've compared them all. And if they all match, then you'll go ahead and mark that to the user as successful. Let me see if I can bring up this demo that I put together. Apologize, it's a bit big. So if I were to type race car, check palindrome, it is a palindrome. So that's what you'll be working on tonight. And again, I highly recommend working on the projects. That's going to be something that's very helpful for you moving forward. So let's dive into it. Strings. Strings are an array or a list of characters. And they're a series of characters that are actually stored as a list in separate values. Strings are constants, and that's going to be key in Java, which means their values cannot be changed after they're created. So when you create a string, if you want to change it, what happens in the background or in the foreground for you, you just assign it a new value or change it or whatever. But in the background, what happens is the first string is destroyed in memory, and then new memory was reserved, and the new string is placed there. And that's going to be big when we get into StringBuilder, because that's a lot of overhead to be able to have to destroy it and remake it. So that's something you got to keep in mind. Like we talked about, StringBuilder will allow you to use mutable or changeable strings, and we'll touch that near the end of the module today. Strings are also defined with a double quote. Like we've been doing, is you use two quotes, and then everything in there is a string, and the single quote is a character. You can see here, this is an array or a list of characters. So this right here, these two lines do the same thing that this line does. It's saying, hey, here's a list of characters, and I want you to use it to build a string. Here is a string. So all words are treated as string objects, as we'll see. So let's see a little bit of that right there. So you can see already our hello world. Make sure to bring up Replit. We'll be following along and doing additional things as we go through, but this one's, we'll just look at this. So you can see here, this is what's called a string object. It's in fact called a string literal, because you are literally defining the string how it literally will be. But you notice if I do a dot here, well, that's anticlimactic. It took a second there. You can see here it's giving us the same thing as if I were to use any other object, like our integer object or system or out or anything else. It's giving you a list of methods that you have there. That's because Java will convert a string literal to a string object automatically. So you have access to all of these different things, your equals, and we'll touch on a good number of these today. So anything inside of the double quotes is a string, and that allows you to manipulate and show text to the user. Let's see how we can manipulate that text. So the next objective is that you can use a string methods to manipulate string text. So you can see here, multiple strings can be concatenated or combined with a plus symbol. Remember, it doesn't change the original strings. It combines the two to make another one. So you can see that example here with hello world. You have hello plus world, so they take these two, combine them together, and store them here, and then these two are destroyed. We also don't compare strings with our equality operator. This compares the address and memory where the strings are stored and not the strings themselves. Instead, what we use is called the equals method. You can see here, so we have our string, our hello string. We assign that a value of hello, and now we do hello, so accessing this strings method dot equals, and then we're passing that hello to check to see if these are both equal. And since they are, we'll get a true value on that. All right, a true Boolean is returned to us. You could also access a string with the symbol, with the method char at or char at. So you can see here, we take our hello string from up here, and we're using a character at, and we give it a 2, it gives us an L. And this is just, I just named these to help them be easier and clearer. But you can look at this, 1, 2, our second string is actually, our second character in our string is actually an E. So in fact, what's happening here is in programming, almost anything, you might as well just say anything because there are exceptions, but not very often. Lists are indexed by 0 values. So this is the 0th string. So you have 0, 1, 2. There we go. 2 is right there. That's going to give us the L. So you'll definitely want to keep that in mind. And from now on, start counting a 0. And that's going to be really helpful. A reason that is done that way is it conserves memory. Just slightly. But if you have a character or a string that's 2 characters long, to represent a 2 in binary, in fact, uses 2 bits. But if you do 0 and 1, then that's a single bit. So it's really just going to give you 1 extra bit in half of the cases. But when you use arrays and strings and all these things thousands of times in code, now that goes from saving you 1 bit to 1,000 bits, and then it starts to get more and more, especially if you deal with stuff like on Google scale where you have billions and billions of strings, then that starts getting huge. The amount of data that single bit per character can save you. Next, you can use the replace method. So you see here I'm using replace last. That's because it will replace the first or last occurrence of this. Actually, in fact, it'll either replace all of the occurrences or just the last occurrence of whatever character you give it here with this. So this is how, and then finally you have your substring, which gives you, it just chops up the string that you have and gives you a smaller part. So let's dig into what this whole line does. So what it's doing is we're taking our hello string, which is right here, easy reference, substring, it's taking 0, 1, 2, 3, and in fact, this should be using the last one, so it's not going to give us help. And I'll show you why that happens. But it's going to take the first few, and then it's going to replace the last space with a P. But since it doesn't have a space, it's just going to give you, it just won't replace anything. So what you'll end up with getting is, with this line of code, you're not going to get help. You're just going to get hell. In fact, that's a poorly written line of code. Let's fix that. Let's jump into Replit, and now follow along with me. We're going to play around with different string methods, and I'm going to do it all inside of a print line, so you can just see that. So I'll delete that. We'll just come up here, and we'll create our string. We don't need to do this, but for clarity's sake, we'll do it. Hello world. So what we'll do here, we need a semicolon there. So let's just get hello. So what we need to do is first we need to name our string. There we go. Now that's properly done. So now we can get hello dot let's zoom in just a little bit. Let me make sure also that I have the chat window up. There it goes. Sometimes Zoom doesn't like to show me chat. There it goes. I see that. Sorry for missing a couple of those things, guys. We got it zoomed in, so now we can see it a little bit better. We're gonna go hello dot, and we're gonna do a substring. And we're gonna go 0, 1, 2, 3, 4. We're gonna go 0 to 4. And now let's run that. Wait. We're only getting, we're not getting hello. So what's happening here? What's happening is, let's use our cursor as an example. I was practicing this earlier. So this is a good way to count things out. What you have to remember is there's inclusive and there's exclusive. So the way this is set up is you have your 0th character inclusive, and then your character index 4 is exclusive. So that's something you just have to practice and remember. So I have the character here. This is kind of how it works. I go character 0, and then I'm going to go 0, 1, 2, 3. Oh, I was practicing that. It didn't work. 1, 2, 3, 4. So our character at 0, this is what's happening. Your character is at 0, and then we move into 1. And then we move to position 2, 3, 4. So what's using is we're moving our iterator, or in this case, our cursor, starts at 0. And if I were to pass 0, it would give me nothing. In fact, let's do that. Might even throw an error. So here you go. Yep, it just gave me nothing. It just printed a line that was empty. That's because we 0 and our cursor's still there. But if we go 3, like we had in the poorly written demo code, 0, 1, now we have the H, we're going to 2, and then we have the E, and 3, and we have just H-E-L. So that's how this works with inclusive and exclusive. It just drops the last. It drops whatever character you're at. So this one's at index 3, so 0, 1, 2, 3. This L is at index 3, but it is excluded because this parameter is exclusive. So we pass it 4. That should, well, no, it should be 4. We pass it our 5 because 0, 1, 2, 3, 4, 5. There you go, hello. And if we wanted to get world, we would go our 0 index, 1 index, 2, 3, 4, 5, 6. As we want it, so it is inclusive. We're going to give it a 6. And then we start here, we go 6, 7, 8, 9, 10, 11. 6 and then 11, and that should give us world. So there you go. It's the first index inclusive and the last index exclusive. So let's do a couple other things. Let's check that this is actually giving us world. So we go dot equals. This is a little too far zoomed in. There we go. Make sure we have the right number of parentheses. There we go. And we're just going to go world. And in fact, we're missing the paren there. We delete that one. So now we have the right number of parentheses. Let's move it a little bit. We don't need that space. So if I run that, that is false because these are all capitalized. So one thing you can do too is, let's change this. We're going to go to uppercase and run that. So this is another method that we have, and it'll convert whatever we have here to everything's uppercase. And then you have 2 lowercase, And then we can put that right here as well, dot to lowercase. So you can see here I'm putting it inside of the equals parenthesis because I'm doing it on this string, not on the other string. So if I run that, true. So you can see here is what's happening is we're taking our hello world string, we're grabbing these 5 characters, we're converting them all to lowercase, and we're checking to see if this converted to lowercase is equivalent. This is a good thing to use, kind of a good rule of thumb, is when you compare strings, unless you want specifically to compare case, uppercase or lowercase, just convert them both to lowercase, no matter what. That way you can just say, do they have the same letters? And if they do, they're great. If they don't, then you'll know that. And you can see here, this starts to get a little bit more complicated because everything's there. Let's zoom out a little bit so we can get it all in one line. So I want to walk you through how this is, how this works. So what's happening is we have a string here, and if we use substring, it's going to return us a string. So then at this point where our cursor is, we have another string. So then if I use to lowercase, it also gives us another string. So then we can use the dot equals because that's a string. And then we finish here, and now it's no longer going to be a string, it's a Boolean value. So this returns a string, this returns a string, this is a string, but this returns a Boolean value. So that's going to be something really important, and it's all executed in order. And that's the same thing with this one. This is a string, and so we can call it that method. This is called chaining functions or methods, because you can chain things together as long as they return the value you're looking for, or the value required by the next one. So let's jump back into our PowerPoint. Let's first make sure we got everything. Oh, finally, let's just comment that line. Let us do one last thing. We're going to get hello.char at, and it's going to use the index like we said before. So if we want to get this W or the exclamation point, in fact, let's do a trick. Exclamation point, what we want to do is this is going to be our last character. So in order to get the last character in a string, you need to do, you have the length method. So you hello.length, and that's going to return the integer value, which is equal to however long this is. But you can see here, string index out of bounds exception. Because when you're counting the number of something, it starts with 1. But the index of things in programming start at 0. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, this length method here is giving me 12. But if I use the index value, so that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 gets me out of the string. And that causes a runtime exception, which is the string index out of bounds exception. So it's saying at line 12, oh no, this is in fact, it's saying the index value, the index that we're giving it is 12, and that's out of range. And if you look here, our main Java, because this is the string Java file, we're looking at the main Java file, and that's line 6. So I can see line 6, it's giving me a 12, and that's too big. So what I need to do is I need to do length minus 1, and that will give me the last character in the string. So if I run that, that gives me the exclamation point. So now let's do one last thing. I keep wanting to let you go, but then I keep thinking of fun or important things to show you. This, hint, hint, double eyes on the prize, this is going to be helpful for your assignment tonight. We're going to do a for loop, so follow along with me. Get your fingers on keyboards. Make sure you're all following along on this one, because you'll want this in your brains. I is less than hello.length. And remember from a couple of days ago, if we're using less than, we won't run into the index issue, because when I gets to 12, it is equal to the length, and it won't execute this code. Let's print this in reverse. So what we're going to do here is I'm doing a for loop, and I'm printing it. But this, I don't have I anywhere in here. I'm not changing anything with my index. So it's only going to print the last character multiple times. So if I do this minus I, so that's saying I want you to print the last character in my string offset to the left by I. And then let's change that to, instead of print line, we'll just print. So the only difference there is instead of printing each thing on each statement on a separate line, it'll print them all on the same line. And if I run that, there we go. We just reversed our string. So this is something that's going to be really important for you to remember right here for the assignment tonight. When checking for palindromes, you'll want to reverse this. You'll want to compare forwards to the reverse. So that's going to be helpful in finding your reverse string. In fact, that line. So keep that in mind. Hope that was worth the extra couple of minutes. So now let's look at the benefits and drawbacks of StringBuilder. So as I said before, string concatenation, so using your plus symbol to combine strings, that's not going to be very efficient because strings are constants. So StringBuilder allows you to use, it's an object that allows you to concatenate the strings more efficiently. So first I want to show you how to use it. So we're going to work together on this one. And then I want to show you the difference. So let's delete this, delete that. So now what we're going to do is first we need to follow along with me. Make sure you follow this. That's easy to forget. We need to import the java.lang, so the Java language.StringBuilder. So this is a Java library that allows you to import this. So just like Android libraries to make your code smaller, same thing as we'll just import StringBuilder rather than importing the entire Java language. So in the basic language, you have the things we've been working with. Now we're adding on StringBuilder. So in order to use StringBuilder, builder equals new string builder. I just need to learn how to type. So we're creating a new string builder. And in order to add something to your builder, use builder.append. And then you could append, if you notice, let's go back, builder.append. And this shows you all the overloaded, remember from Thursday, all the overloaded methods that are overloaded versions that append has. And this just shows you you can pass in practically anything. In fact, because you can pass in object here, it means you can pass in anything. And it will append it. Who knows if it's formatted any readable way, but it knows how to handle it. But specifically, it can handle all of these things, and it knows how to do that. So if I do .append, and we're just going to give it a string literal. So I'll just do 1, comma, space. And if I, and then we'll come down here, give it a couple of spaces, system.out.println. We're going to go builder.toString. So what this is doing is so we create a new string builder. We're appending 1, comma, space to the end of it. And then we are converting that to a true string. And if we run that, we'll get 1, comma, space. But that's not very useful. I mean, that's 3 lines of code just to do a single string literal. Where it shines is if you're doing multiple. So if I do append 2, so now we're going to 1, comma, space, 2, comma, space. And what if I want to do append 3? So you can see how I can pass it multiple variables. They each have, that's one of the downsides of builder is they have to be each in their separate append statement. But if I run that now, we get 1, 2, 3. And then finally, you have the insert. Your insert method. So if I do insert, I want to insert, it's looking for our index. So if I give it at 5, and then I want to give it an underscore, I can do 2 underscores. And if I run this, so there you go. 0, 1, 2, 3, 4, 5. So the string that we gave it starts at index 5 and puts those 2 there. So there's StringBuilder. But now let's see. I'm going to jump back to this code that I have already written. And this is going to show you the power of StringBuilder. So I have, let me walk you through what this code does. First, instant. This is used as a stopwatch. So I can, instant and duration. So what it's doing is it's starting the stopwatch, stops the stopwatch, or just tells me, I shouldn't get, this tells me this is storing the time it starts, time it stops, and then this is getting the duration between the 2 of those. And it's going to print that to the screen. Next, it'll start another time and end another time and show that. But right here, what's happening is first I'm going to take a string and I'm concatenating it. This is another trick. This line is equivalent to, whoops, copy, paste, equals, concat, string, plus. These 2 lines do the same thing. But since we have the plus equals there, it's just easier and shorter to write. So what this is doing is it has 0, and then it's doing a for loop where it's adding each of the numbers to it. No lines, just the raw numbers from 0 to 1 million. And that's using string concatenation. And this is using StringBuilder. So what we'll end up seeing is we'll see this line printed out and this line. The first line is going to be how long it takes with concatenation. The second line is going to be how long it takes with StringBuilder. And as we'll be able to see is because each time I add a number these million times, and million is probably a little bit too long. In fact, let's stop it. We're going to change this to 100,000. Each time I add a number to it, it's destroying concat string, reserving new memory, and putting something else on. And then with here, what we're doing is it's just building up a list. And then when it's ready to go, you can convert it to a string. And in fact, that's one thing that we should probably test as well. If I go, exit status 1, it doesn't like that I changed the code. Just run that one more time. Java or Replit could just be not liking me today. I've had to do way too much stuff to get that going. Yep, that's not, it doesn't like it. So let's do a quick refresh. Insufficient, yep, this is the log that Replit's giving me. There's insufficient memory. It was probably didn't like that million that I was running. This should take only a few seconds. So we'll give it a couple more seconds. Yep, it is just not liking me today. So let's do this. Delete that. Yes, delete this file. Let's jump back into Android. What I wanted to show you is that StringBuilder or concatenating string for 100,000 characters takes about 5.5 seconds from what I tested earlier, whereas StringBuilder takes like 300ths or 3,000ths of a second. It is much, much faster when dealing with large numbers like that. And even when I was trying to figure out where concatenation is faster than StringBuilder, I got down to 10, just doing 10 concatenations, and StringBuilder was still faster. So now let's go into string interpolation. String interpolation is the way you can format strings to have it automatically formatted. And it can be a little bit confusing, but let's walk through and we'll see how it's done. So let me show you here. This is a basic explanation of what you need to do. And then these are some examples over here. So first, you have your, anything in braces is optional. So if I go, you have your argument index, you have your flags, you have the width of the entire thing, and then you have the precision, and then you have the data type, which is required. So you have to have percent and data type, and show that here. This is the very basic of what you need. But this is how you can insert, doesn't necessarily work with string literals very well, but you can insert values there. This is kind of the beauty of it. So you can take something that I don't know what this number would always be. Let's say it's a calculation, calculating the amount of sales for the day. I don't know if we had 2,000, 100, 10, a million. I don't know that. So what I can do is I can give it spacing for kind of the maximum value that I would think it would need, amount of space I think it would need. Then I can use this formula to format it. Let's see what each of these things does. So this tells me, okay, I need you to grab a parameter from over here. Next, what I want you to do is I want you to pad it with zeros. So take the parameter, pad anything with zeros. Then I want you to separate each of the bundles of 100, 1,000, million with commas, so grouping separator. And then I want the total thing to be at least, remember the at least, 4 characters wide with a precision of 0.2, and precision only works with floats. And then you can see if I give it 2,500 as a float, remember it has to be a float, it's going to format that as such. So I have my $ space, and that sets that up, and it's not part of this. And then you see added the comma, added the decimal, and added the 2 zeros. And then finally you have your agent 007, where you have, it's just your string agent, and you have your agent's code. I want this to be 3 digits wide, 3 characters wide. It's a decimal, and it needs to be padded by zeros. So it pads it by zeros. And you can see here the different types. You have a decimal type, float decimal type, and then a string type. So let's play with those and see how those go. So I'm going to click run. Now let's jump back into here. So follow along with me in your own Replit. I'm just going to delete this. And you saw in the slide, you don't even have to use it to build a string. Your system.out has a format method that will allow you to format something. So you have to have a string literal to start with. Now let's just do something simple. Follow along with me. We'll just do a %d, and it's just going to print out the number 5. So there you go. Printed out the number 5. Another thing too is if you use \n, this is called a new line character. You see here it printed the 5, and then this is on the same line. If I do the \n, it will print 5 and then return. So that's a good thing for formatting as well. But that's not necessarily, that's not part of string formatting. So we'll just move that out of the way so we don't have to see it. So now let's play around with, we want it to be a little bit longer than that. If I have a 5 and if I have a 500, I want them to take up about the same amount of space. So let's pad it with, let's make it at least 3. And this time we're going to pad it with spaces. Let's run that. There we go. Let's see what happens if we pad it with zeros. I think padding with zeros only goes on the right. I could be wrong. Oh, nope, there you go. There, it's padding our 5 with zeros. So it's a 0, 0, 5. In fact, my example was padding it with zeros. I should have remembered that. So let me show you an advantage of this. So let's say we have, there you go. We have a 3-digit number and a single-digit number. We want them to be aligned. There we go. So now they're aligned. They're taking the same amount of space. If I change this to padding with a space, it'll make a little bit more sense. There you go. So now let's try something. Let's do a sample payroll. System.out.println. If you ever used ASCII art, we're going to do something similar to that. So first we will do name, and then we're going to go give it a few more spaces. Then we will do age, and then we'll do salary. We'll probably have to play with these spacings as we go. But if I copy that, paste that down there, and now we will just do our dashes to separate it out. Then we will just print out a blank line to space this out there. And now let's build this out. So what we're going to want to do is let's start with, in fact, we can delete this and start from scratch. Here we're using the print line, so we don't need the return character because it has that built in with the line. If I were to just do print, then you'd need to use a new line character. So first, our name is going to be a string. So we'll do our percent string. In fact, I'm just going to delete this whole thing and start from scratch. We're going to have our new line character. And we're going to have a string. And then we want that string. Let's see here. We have 4 characters here. I think we'll just do a single. So we do a first name, and then first name, what, we give it 8 characters, you think? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, we already put 9 here. Let's do that. We'll have it be 9 long, and we're padding it with spaces. And in fact, one thing we can do as well is that we will left justify it and pad it with spaces. Actually, I think we just left justify it, and everything on the right will fill that in, but we'll experiment with that. Next to the age is going to be a digit. It's going to be decimal. You can see I added a space here manually. That will add a space no matter what. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then a space, and then we get to our age. We were going to left justify that as well. And we're going to, we want that to take up 3 spaces? Yeah, we can do 3 spaces. Because that's just the width of age there. So we can always have it be 3 or 2 if you want. You could also do 2 and then manually give it a space if you don't think you have anybody with 3 digits. And then after that, how many spaces do we have? So we can count out, we have 1, we set a 9 here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we give it a manual space. There's a manual space. And then we had 3, 1, 2, 3. And now we need to get to salary. How many spaces to get to salary? 1, 2, 3, 4, 5. So go 1, 2, 3, 4, 5. And now our salary is, we're going to format that as money. And in this case, we're going to say somebody can, actually, let's change that to hourly, and we'll just do hourly. So it makes a little more sense conceptually. And that's going to be a float, because your hourly rate is going to be a float. And we're going to format that by, we want that to be our hourly rate. I mean, we have space for it here. We have 1, 2, 3, 4, 5, 6. So that gives us 2 decimal places and then 4 regular places. So we could, well, 4, and then we have to have a dollar sign here. So I do the dollar sign. 1, 2, 3. So we got 3 digits. So we have dollar sign, 2 digits, a period, and 2 numbers. So maybe we'll do a 4.2. So that's saying I want it to be at least 4 spaces, 0.2. So now let's put our data in. We'll go Billy. Oh, whoops, that needs to be a string. Our string for Billy. Then we're going to give it our age. His age is 24. And then his hourly rate is 11.25 as a float. So let's see how that turns out. See if we format it all correctly. Okay, there we go. So you can see here, we have Billy left justified, and then we gave it enough spacings. So he has 5 in his name. So 1, 2, 3, 4. So 5 plus 4, 9. Then we have our static space, and then we have his age, which is 3 spaces. And then we gave it our 4 more or 5 more spaces, and then we get to his hourly wage. And that's a total of 4 characters long. And in fact, let's try this while we're looking at it. And then you have your decimal and your precision of 2. Experiment. That's 5. So if I do 6. Okay. So now experimenting with this, I'll show you what I should have walked through this with you. Our 4, in fact, this is 5 characters long because it's not only counting the numbers, it's also counting the period. That's why we had to put 6 here for that spacing to show up. So what we should do is we should do 5 there. And now let's run this with a different data. There we go. Shift tab will turn you back, and we'll just go. Sally is 23. She makes $12.63, and then you have George, who's 18, and he only makes $9.75. So let's see how that looks. Remember, we're using all of this. We're the same formatting. We're just giving it different data each time. And they should all align because it's left justified. We have all the spacing that we want. The numbers are all less than the sizes that we're giving it. Holy cannoli. Let's check back with that. Yeah, that didn't work again. There we go. Thank you, Replit. So everything's still all lined up. Even though George is longer, he's making less money. It's all lined up because we're using this string format. Now, this isn't necessarily the... this is a lot of excess text. Let's try something that I haven't tried before. So if I cut this, let's do string format employee format, and we're going to assign it that value. Now if I pass in, I'm just going to copy and paste that employee format, that should work because a string is a string, which is a string and a string. So this is another way to cut down on a lot of your typing. And then even more so on what you'll actually be doing, because you're not going to write programs that hard code data like this. Most likely is you'll have these values in a object, and then you can use a for loop to walk through it and grab all the values that you want and then display them. So it's not yelling at us, it's printing slowly. In fact, it doesn't like that. So it does have to be your string here. Unless Replit's just being obnoxious. I think Replit was just being obnoxious. Well, we'll come back to that later and see if it's made up its mind on what it wants or not. But that kind of shows you the power of string formatting and string interpolation. So now let's go into one Android specific things. Now you got all your Java out of the way. Android uses things called string resource files. In fact, you'll probably have seen error messages or warnings referencing this. So what that is it's a file that holds your strings. And in fact, ignore this text here because that is definitely copied from another slide. So in order to provide better localization, translation, Android recommends using a resource file, a string resource file. You access it just like you access your IDs or your color resource file. You just use your R for capital R dot for resources dot string, and then you access all the strings here. So this is an example of just the app name, Rainbow, from the other day. And then what happens is you have different files for each language, and the system will grab the file according to the selected language that the user has selected in their Android system. So let's look into that, and we'll look at a string resource file. So open up Android Studio. Remember, a good rule of thumb to always have Android Studio opened during these projects or these lectures. So let's do a string demo. So next. Actually, one thing I'm going to do is I'm going to bump this up so I can show you something else. Let's go all the way up to 28. Next, finish. If you already started it without that, you're fine. You don't need those higher values. So you can see it's building up. And I'd also, while this is building, I'd like to direct everyone's attention to the chat. Thomas was very kind to construct a boat for us because my lecture is so boring, understandable, that he needed to construct a boat to amuse you all. So I hope you get proper amusement out of that, out of his pain and suffering in constructing that. Some of these conceptual things are just, you just got to drive through it, take your opportunity to do the exercises together, and that's where you got to get through it. When we get to some of the more things like notifications is one of my favorites, where we can think as developers and as users what the user would want. That's a great thing that can show you where you can get advantage of discussions and questions and things like that. Okay, so now we have our project. Let's go into our resource here. So we can say hello world is fine, but if I change that to your string here, you can see it's yelling at me. See this is highlighted in yellow? That's telling me there's a warning here. So let's see what happens. In fact, right here it says hard-coded string. Your string here should use a @string resource. Sorry, I can't make that bigger right now. So if I click this, well, in fact, let's do this. So if we go into app, resource, values, strings, and this is our string resources file. You see our only string resource that we have right here is our name of our app. So if I do another one, string name, string here, follow along with me if you can, and then do your string here. So now what this is doing, this is creating a string resource and saying, okay, it is called string here, and this is the value. This is a little bit confusing because in with XML, having these values here, it's not in the resource files. These are not accessed programmatically. It's like this is parsed by, by Android and saying, okay, here's a string as a resource. This is just pulling it from the file and storing it. It's easier to type the stuff because you don't have to worry about something like if I have a string here and then I want to put a quote there, it cuts that off. What you have to do is you have to use your escape or the escape key. Oh, that's not going to work there. That's not a good example. If I go here, if I go main, and I go string, and I put a quote there, it breaks that. But if I use the escape character, it is now saying, oh, that double quote, that's part of the string. So the way XML is parsing it, you don't need to worry about that. But anyway, I have that there. Now let's go here. Or no, let's go back to here. And now we can say, okay, let's use a string resource. Okay, I'll use a string resource. at string, and you can even show string here. So what's happening, if I open this up, it's giving me this error here. This is a bug with the most recent version of Android Studio. It has issues with rendering. If you run into that, I've showed it already, but it's always good to show it here. You go to your styles, and you just change this to base dot. And then you can come back and it'll render properly. String, oh, it's because it's not a string here. It is, if we look here, our name, that is string here. We can just try refreshing the layout. That'll probably help. Anyway, it's not a class unless something breaks, and we've had a few things break today. But that's fine. That's how you can access that. And what that does is it puts your string value here, and it'll stick it into here. And if I build it, it will definitely show. Hide that. It's building. There's our palindromes again. So one thing let's do, let's duplicate this. Highlight this, Control D, duplicate it. I want to show you another tip to be able to do that. My string here. You can see here that it's still yelling at me because I don't have a string resource. But another thing you can do is if you click this light bulb here, you can click Extract String Resource, and it'll bring up the resource extractor. What you can do is this is suggesting, hey, do you want to name your resource this? So no, let's just do my string. When naming your resources, you don't want them to be exactly what they are because sometimes you'll want to change it. What you want to do, it's just like an ID. You kind of want to talk about how it's used or where it's used. So it could be my string, which is enough to say, another thing is where it's used, how it's used, or a generalization of what it's saying. Like if they have a whole paragraph, if you have a whole paragraph explaining to the user how to use your app, instead of having the whole paragraph, what you just do is app instructions. Something enough that you can know, look at this name, okay, that's what it is, and then you're free in the back end to manipulate that. But I'll just change this back to my string. I do okay. I come here. It has now added my string, and you can see it's not complaining to me anymore. And you'll actually see as well, text view, text. If I come down here, text no, we'll just do text dot set text. If I give it a string literal here, demo text, oops, it's going to complain to me as well. As soon as it stops losing its mind, it would say, hey, this is a string literal. You don't want to have a string literal here. You should put it, there it goes. You should put in your string resource. So I can do that. Generally, if you could highlight this and move over, but you should also be able to right click it. Or let's try this. Highlight it, right click it. Nope. My computer is just all, what was it messed up? So let's just go up here. In fact, it'd be better to show you how to import it. So if we do string name, and you can always just duplicate these and change it where you want. Demo text. And then I go into my main activity here and I'll delete this. In fact, let's risk it. Text dot set text. And you can see here, you can pass it a character sequence or character array, but you can also pass it just the resource ID. So if I do r.string.demo text, and that's fine. If you want to use the string for something else other than just setting the text, or if you want to combine it with something else, what you'll have to do is you do get string, and then you pass it r.string.demo text, and then you can treat this whole thing as a string. So if I do dot, doesn't like me, replace, or append doesn't work, char at. So you can see all of these things. You have access to all those methods because we've imported this string and it's doing the method, the exercises on the list methods. And you can see also our your string here has appeared there. So that's been all of the topics for today. Let's dive back to the assignment, and I will show you. So here are the instructions on this repo. So if you go to the site that's on the slideshow, so github.com/lambda-school/Android strings, you can read these instructions and you can see how all this is done. And remember, this is showing you how to step through a string backwards, but we've already done that. You've already done that. You know how to do that now. But you go forward, compare it to the back one. When comparing characters, you still use the assignment operator, or not the assignment operator, the comparator. The character doesn't have a string. So if you char at index 1, you can't do dot equals because it's doing a character. Dot equals is only for string comparisons. You can use a comparator for just a single character. Finally, you'll build, run, and test your app. And then you'll compress the project into your zip directory and send that to your PM. If you have any questions, PMs, that's what they're here for, is to walk you through and help you with all these things. Not necessarily walk you through it. This is enough walking through, but to help you out if you run into issues. A bonus challenge will be an app that ignores capitalization. And so you'll want to convert that to lowercase, like I showed you. And you'll replace your spaces and punctuations when checking it. So you can compare multiple words and words with punctuation. But that's strings for you. We went through all of that, and we're actually not too late. I really appreciate you all there. And then if you do have issues, if there's anything I missed in the chat, feel free to DM me or any of the PMs, and they will help you out with that. Thanks again, guys, and I look forward to meeting with you tomorrow where we go over something else, and we're going to build another cool app. Have a good one, and talk to you later.